All right. So we will start this class with this problem, which is based on three particles. I'll explain this question to all of you, and we will use a different concept to solve it. The problem in hand here talks about three identical balls A, B, and C, which are connected with the help of two rods, and both these rods are having length of L each. And the question is somewhat like this, that at t is equal to 0, you have given velocity to one of the rods. Let's say ball A is given instantaneously a velocity which is perpendicular to the rods. Let's say that velocity which is given to him is V0. And fine, like gravity in this problem is in the cross direction, and table here is frictionless, right? So the question now is, if this structure is moving on this frictionless table, we have to find out minimum distance between A and C. So what is the value of d min between A and C? That is what we have to find out in the problem. Now, generally in such type of problems, we talk about conservation of linear momentum, energy, and angular momentum. If you look into the problem, right, if you look into the problem, the analysis of this problem can become a bit simpler if we talk about the C frame in this question, right? So we need to analyze this problem from the C frame. And we are clear that if these three masses m each, right, are given, then center of mass, which is initially on B, is having some velocity which is V0 upon 3, right? तो एक बार C frame से अगर मैं देख रहा हूँ, this is VCM. So if I'm going into C frame, what do I observe here? For A, B, and C, what do I observe here? From C frame, B will have a velocity which is V0 by 3 down. C will have a velocity which is again V0 by 3 down. And A will have a velocity which is V0 minus V0 by 3. So that value is 2 V0 by 3 up L here. Now, remember, B will not behave as center of mass of this system always. So wherever is that hypothetical space point, which will keep on moving on a straight line, if you observe from this frame of reference, this system will orient itself into a isosceles kind of triangle. So I will try to draw that orientation, but that is not on scale. So what I'm trying to say is, these three people can align themselves into some pattern where I've got some B somewhere, I've got a position of A somewhere, I've got a position of C somewhere. These are the rods, the length L, something of this sort. This may not be 90, it can have some orientation. And we understand that this is the line of symmetry of this problem. So center of mass is lying on this line, but it keeps on moving on a straight line also. So we keep on making the structure which is somewhat like this. Now there are a few things which we can comment upon. When you say that distance between A and C becomes minimum, now this statement has got significance in this problem, right? Minimal distance between A and C. I'll explain what I'm trying to say. Distance between A and B is already fixed, L. B and C already fixed, L. When you talk about A and C, when you talk about minimal distance, that means at that point of time, the rate of change of that distance is 0. At that point of time, the rate of change of distance is 0. And remember, in this problem, B is a pin support kind of place, an axle, a pin support. And there is rotation which is possible about this point, BC, rotation about this point, AB, that is possible. So if you talk about the same in this question, and AC rate of change is 0 at that stage, so I can say in this stage, in the final stage, this system momentarily behaves like a rigid body. Momentarily behaves like a rigid body. The complete structure. By definition, obviously you have only 3 point masses. The definition says the distance between any 2 point mass should not be a function of time. So at that instance, from dt by 2 before to dt by 2 afterwards, the distance is not changing. So abhi to rigid nahi hai because AC is changing. But at that instance, it will be rigid. And this idea is going to help me out in the problem. How come? So let me now make some statements. So go step by step. I will go into the frame of reference of center of mass. The first equation that I can write is, what is the kinetic energy of this system from C frame? So kinetic energy of this system from C frame, only 3 point masses. So I have half m 2 V naught by 3 term, इसका square term है. Then there is half m V naught by 3 का whole square वाला term है. और ऐसे 2 terms हैं, ऐसे 2 terms हैं, तो twice of that. So effectively what I am getting is, I have got a mv naught square term, a factor of 2 by 9 is there, and this will cancel out. This is m v naught square upon 9 term is there. So 3m v naught square upon 9. So that becomes m v naught square divided by 3. Keep this term as such, the net energy. Second point, from the C frame, I am interested in writing the angular momentum of this system. Let me write the angular momentum. Let me denote it by capital L. And I'm trying to write the magnitude of angular momentum from C frame. We understand this thing that C being inertial frame of reference, so there is no pseudo which will come. So no one can provide torque about it. So about center of mass, the angular momentum of this system should remain constant. So do one thing, try to write the angular momentum at t is equal to 0. Let's see what comes up. So C frame say L initial likh raha hu pehle. So let's see what will come up. This won't have any angular momentum. It will have m into 2 V naught by 3 ka term multiplied by L. That is clock. And this term is also there. So that is m V naught by 3 multiplied by L. So what is the angular momentum of this system from C frame? That comes out as 3m V naught L upon 3. So basically m V naught L term. So my angular momentum comes out as m V naught L. Now again, I want to go to the final state. Right? Again, let me make my final comment. Again, in the final state, whatever is the orientation of the rigid body, we are convinced that the complete body is acting in a rigid way. Earlier, there was a pin joint, so I proved it. So if that body is rigid, so can we write that P square, like L square upon twice of moment of inertia, this term is the kinetic energy, the energy E. But if the body is rigid and it is in a state of pure rotation about the C frame, then the total kinetic energy should be written as L square by twice of I. That means the moment of inertia I should be written as L square by twice of E term should be there, L square by 2E. Good enough? And that makes what? That changes the problem because already L I know is constant in this problem, which is mv naught L. So this becomes mv naught L, the whole square, upon twice of E. And what is E in this problem? So that will become mv naught square by 3. This will become mv naught square divided by 3. So if you look into this expression, this comes out as 3 by 2 ml square. Observe that. your moment of inertia comes out as 3 by 2 ml square. Now I will go back to the track. Now again, I have calculated I about cm. This everything I'm writing about cm, L about cm, this cm, kinetic energy also. So I cm मुझे मिल गया, है ना? E, obviously from that frame, there is no additional force which is coming. So from that frame also the energy remains constant. There is no pseudo force. उसका कोई work तो आया नहीं. Potential का कोई term है नहीं. तो E तो उसका इतना ही आ गया. Whatever was the initial kinetic energy from C frame. So with respect to C, the total kinetic energy always remains the same. तो मैंने यहाँ से LCM, ECM I substituted. I got ICM. And now it should be close. Because we knew this thing from symmetry of the problem that in that state, in the final state, it will have some orientation which is like isosceles triangle. Technically, two rods. I mean, the intermediate rod was B. So this was B, this was C, this is A. You were interested in the minimum distance between A and C. That was the question in hand. And we understand that somewhere on this line of symmetry is our center of mass, And this is L, and this is also L. These distances are L, L. So I have got this expression of ICM. If I can write this expression again, there's a mass M here, there's a mass M here, and there's a mass M here. If about center of mass, I can write moment of inertia, my purpose is solved. So the question is to write the moment of inertia about center of mass. And now, for that thing, let me derive a simple expression that if there is a mass M here, L, L, there is M here, and there is M here, this is D. So I'm just taking this distance as some h directly also. If you wish, you can write this distance is h by 3, and this distance is 2h by 3, total is h. And if this is center of mass, just derive the expression of ICM. I'll write a simple equation, I'll equate it. So I think it comes out as, for the top mass, it is m into 2h by 3 the whole square. And there are two people, m into, and you understand this distance square, which is, if this was a d, so let me write d by 2, d by 2. So d square by 4 plus h square by 9. This is my ICM, first equation. And obviously I know that h square plus d square by 4, that is equal to L square. Using these two equations, right, just try to write this complete expression of ICM in terms of L and D, MLD. I want to write it in terms of MLD. And that comes out as m by 3 times, we solve it, it is 2L square plus D square term is there. Just a small recap. If I want to write the moment of inertia, whichever way you are comfortable, you need to have this expression. If you had this expression of ICM, I can directly jump back to the problem, and I would have directly said that this should be equal to m by 3 multiplied by 2L square plus D min square. That is what this equation is all about. If you solve this equation, you should get your result for D min versus L, and that should be the answer to the question. When you solve it, D min comes out as L root 5 by 2. This is the actual result of the problem. I'll repeat the statements again. This last step that I have taken here is only helpful in that sense that somebody who knows the moment of inertia, once he knows the moment of inertia, he knows the distance also. The concept which was important in this problem was that can a student think this point? The C frame was obvious. From C frame, momentum is always conserved so that we can see. From C frame, because it is inertial, kinetic energy could have been conserved because, in fact, the total energy is conserved, but there is no other form of energy. So I conserved the energy. Angular momentum was conserved. And the important point in such problems, whenever there are hinges, and he talks about minimum or maximum distance between two more points, then that line also becomes rigid for that moment. And for three masses, only three combinations were possible. All the distances are constant, so the complete structure is rigid. So apply rigid body mechanics. And problem became quite easy, and you got this. There is one more result which I could have directly used. If somebody doesn't want to use it, I won't derive it. Just to recap, it's a theoretical point. When you study theory, it must have been done. So I'll recap that result for you. So that result is moment of inertia of a system for multiple point masses. You know, if there are a lot of point masses, then moment of inertia of the system about the center of mass is sigma mi mj ri vector minus rj vector squared. This term will be there. And this is whole divided by sigma over I mi. Just try to observe, and that is the mod square, remember, right? So this is the mod square. So if this is I about the center of mass, and center of mass is being treated as the origin also. So if there are a lot of point masses, continuous system also you can apply, but you have to take the integrals. So point masses ke liye, about center of mass, if I want to write the moment of inertia, I'll write this equation. I'll take all the combinations. So you understand, I mean, agar ye sawal hota paper mein, so I would have taken m square everywhere. And denominator total mass is 3m. And then just distances ke square ka sum. So I think you got it, L square plus D square. So basically directly I would have got denominator is 3m, and there is m square common, and there is 2L square and plus D square. So in exam, I would have cancelled this. This is direct result. So m into 2L square plus D square. This is D square. D square, this is 2L square, right? And then you will. So just try to recap that, and rest will be fine. Okay, let me take up the second problem for the day. Now again, this second combination was a nicely built up combination based on energy calculations. Read it carefully. What does the problem say? Actually, in this problem, there is a solenoid. It has got a length of 20 centimeter, solenoid of length L. So that is given. This is wound around a vertical cylindrical test tube made up of glass filled with water. So you can see that. The solenoid is thermally insulated from water. That's fine, no heat interaction. The height of water level is approximately 20 centimeter above the upper end of the solenoid. Diameter of test tube is 1 centimeter. Number of turns in the coil is given. Atmospheric pressure again given, 101 kilopascals. Temperature of water bhi diya hai, 293 Kelvin. Now he has given magnetic susceptibility chi. And value of chi is mu r minus 1. That is given. And mu naught value, that is also given. So what is the question like? The current in the solenoid is slowly increased. तो बढ़ाते हैं इसमें. If the current in the solenoid is slowly increased until the water starts boiling inside the coil. तो आपसे ये पूछा था, at what current strength, that is current, would this happen? And obviously you have to take reasonable approximations when needed. Or when you get the answer, you will be realizing this thing, that in such setups, जो करंट टेक्नोलॉजी है उससे इस तरह की करंट्स प्रैक्टिकली हो सकता है हम अचीव ना कर पाए. So the problem is good because it is based on magnetic energy density का concept is there, and somehow I'll use Bernoulli's also while solving the problem. So 2-3 standard terms we have to write to finally sort out this problem. Now I'll make up the, you keep on thinking on the problem. I'll just repeat the base in this question. So, in this problem, first thing is that if water was not present, है ना, और मेरे पास कोई differential volume है inside the solenoid, so I know that magnetic energy per unit volume there is B square by 2 mu naught term, कुछ तो आ रहा होगा. We will assume that if solenoid was carrying some current and I'm looking into differential volume, I am writing that energy per unit volume as B square by 2 mu naught. And as you fill liquid or water there, that energy converts into B square by 2 mu, and that becomes mu naught mu r term. B square by 2 mu naught mu r बन जाएगा, जो पहले B square by 2 mu naught है. Something of that sort. Now the point is, because you have filled up liquid at some place, the energy per unit, why? One more thing. How come am I thinking in terms of magnetic energy per unit volume? कैसे सोच रहा हूँ? If you look into all the forms of energy, basically I'm thinking in terms of Bernoulli's between two distinct points in boiling water. So when you think about Bernoulli terms, think about Bernoulli terms at 2 points inside a fluid. You're talking about pressure energy P per unit volume. You talk about rho GH, gravitational potential energy per unit volume. You talk about half rho V square. And additionally, in this problem, I will talk about the magnetic energy per unit volume. Now remember, this is a very small sized tube. And one thing is very clear, when you talk about the pressure terms, in comparison to the atmospheric pressure, the rho GH terms are negligible. We are talking about atmospheric pressure in the domain of 101 kilopascal. इसके comparison में जो rho GH term है वो बहुत छोटे हैं. So how come will I introduce the idea? What will I do first is, first of all, I will say that my energy per unit volume, which should have been B square by 2 mu naught, will convert to B square by 2 mu naught into mu r. So that change in this term should be this. B square by 2 mu naught mu r minus B square by 2 mu naught. That should be the change in the magnetic energy per unit volume term. Yeah, Nashir. That is the first thing. Now, we need to understand that when water will start boiling, right? For any differential volume which is present inside the bulk, है ना, वो जो dV है, it will try to come towards the surface, and the pressure that it will be exposed to will gradually become P naught. मतलब जब वो चल के नीचे से ऊपर की तरफ आएगा, है ना, तो it will cross a barrier of pressure, which is some saturation pressure where it starts to boil up to a state where pressure becomes P naught. Or you can say that complete liquid will become fragile and it will be exposed to air, so that pressure will change from that value, which was the saturation vapor pressure at the instance of boiling, to P naught. क्योंकि वेपर सब बनने लगेगा, so you will have space, so the air will enter into that space and that pressure becomes P naught, P atmosphere. So very clearly, this change is happening and its counter is also happening. From a P state, I am moving to a P naught state. So, I mean, P naught की तरफ जा रहे हैं from P state. So that change is somewhat like P naught minus P, P naught minus P. So let me now compensate these two terms. What I'm trying to say now is, by Bernoulli's, what we are willing to write here is that these are both pressure energies per unit volume and magnetic energy per unit volume. and I want to compensate their change. So P naught ka value should come out as P naught minus P की value आएगी plus, and this change, which is B square by 2 mu naught multiplied by terms like 1 by mu r minus 1. This is what we are going to get. This is the expression of P. These are two changes I have written, and now with proper sign, I have substituted the values. इसका जितना change है ना, वही correspondingly pressure energy में convert हो रहा है. In fact, when he says that you need to take a suitable approximation also, as far as JEE Advanced is concerned, maybe this value should be given. Either you give me that saturation vapor pressure, or I will have to assume this term to be 0. I'm assuming absolute lightness, yeah, absolutely lightness inside the liquid, treating it like an ideal fluid at that place, at the instance when it starts to boil, and then it gets exposed to P naught. So whatever is the change in the magnetic energy per unit volume, that gets compensated by the pressure energy per unit watt. So my equation which comes out here is P naught is equal to B square by 2 mu naught 1 by mu r minus. Now there are calculation assumptions. I'll try to write them here. Just check what is that equation getting converted to. क्या आ रहा है आपका? It should come out as P naught is equal to, what is the term we are getting? So minus chi b square upon 2 mu, minus chi b square divided by 2 mu naught. ऐसा कुछ आना चाहिए. Because he has given that equation, chi term that was given to you was mu r minus 1. That is given. One more thing that I have done here is chi upon mu r को लगभग chi लिखा है. Chi upon mu r, it's a valid assumption, is approximately equal to chi or minus chi. ये किया. So after this approximation which I have taken, this is perfectly fine. That is fine. Looking into the values, you can take approximations. Now I don't think there is a big issue because I'll have to just solve it out. P naught का value आ जाएगा minus chi by 2 mu naught multiplied by b square, and that b should be equal to mu naught number of turns per unit length n by L multiplied by I, इसका square. Solve this equation. I think the only unknown in the problem is I, and you can find out the value of I. And when you solve it, generally comes out as 4.4. I mean, around that value is 4.4 kiloampere. The problem is in such kind of solenoids, these kind of currents will create a hassle because there is a unique value of current at which it will rupture. So the material that you need, he has said that these things are practically not possible because actually the limiting current for this size of solenoid is of a very small order, and you are finding out currents which are of the order of kiloampere, which will obviously create a issue, a problem, right? So a problem where he is talking about magnetic energy per unit volume, that term was there. Magnetic field का function भी था, bit of Bernoulli's, and along with the thermal concept, thermal physics concept. So more of a mixed problem on all these parameters. This problem was once put up in US PHO examination also, right? We'll go to the next problem, next idea for the day. So let us pick up the next problem. Let's see. Now, in this question, this is a potato gun, and he talks about the idea. So let us read this carefully. A4. A potato gun fires Okay, just remind me after this question. Yesterday's question, which I have finished, there are two more methods to, discuss that because of scarcity of time, I solved it by one method. I'll just share two more ideas. There are three methods actually to solve that last problem. So I'll discuss the theoretical aspects. Huh? So let me first solve this. Potato gun fires. Yeah. So है क्या इसमें? This cylinder is given, which is closed at one end, open at the other, and there is this potato somewhere inside the cylinder. So cross-sectional area of the cylinder is A. When the gun is fired, the potato slug is at rest, and the volume between the end of the cylinder and the potato, that volume here, so that is given as V0, right? Now the pressure of the gas in this volume is P0. यहाँ फंसा हुआ है P0, and outside pressure is P ATM. वो pressure दिया हुआ है P ATM. Now the question is somewhat like this: P0, P ATM, V0, area of cross section A, and the complete length. Everything is given. Overall length of the barrel may be varied. That's perfectly fine. Now comes the question. So what is the maximum kinetic energy with which the potato can exit the barrel? Maximum kinetic energy जिससे potato can exit the barrel. Now the point is, we understand that, and if you read the data, there is no heat transfer. The potato moves down the cylinder quickly enough that no heat is transferred to the gas. So very concretely, we can think that this segment of the gas here will exhibit adiabatic expansion, and by virtue of which it will exert some work, and that work will be utilized. So as potato is moving rightward, that gas is expanding, so doing some work on the potato, and as it is exerting work, its pressure is reducing. Outside pressure is already PATM, and definitely P0 would have been greater than PATM. That is why it is accelerating. So जैसे से वो accelerate कर रहा है, volume बढ़ रहा है, pressure decrease हो रहा है, so its speed will keep on increasing till the pressure decreases up to PATM, and then it will retard. But the question setter said that to find out the maximum kinetic energy, so what I technically want is, I want this potato to exactly reach here, and reach here at the instance when the pressure inside becomes exactly PATM. If that is the case, then this is the maximum kinetic energy example. This is the maximum kinetic energy. Exactly जिस वक्त वो expand होते हुए L तक पहुंचे, उसी वक्त अंदर वाले गैस का प्रेशर अगर PATM हो जाता है, तो purpose solve है, then that is the maximum possibility. Otherwise, it will further retard now. So its speed will further reduce and the energy will decrease. So how can we go about solving a part of the problem? So let's do one thing. Now, first of all, I write the main equation. So what is the total work done by the gas on the left? So Pi Vi minus Pf Vf upon gamma minus 1. It seems like P0 V0 minus PATM into V final. And V final, so that we should write, what is that term? AL. Yeah, area of cross section is given, length is given, and upon that term gamma minus 1. So we'll see afterwards, that is fine. Gamma in this problem is 7/5. Technically, it seems like this should be equal to what? The maximum kinetic energy of the potato, Emax, plus some work has been wasted against the atmosphere also. So as this gas is expanding, the potato, some work has been done against atmosphere also, and that work has been absorbed by atmosphere. So that term should be PATM, and into the volume change. So AL minus V naught, that seems like that term is AL minus V naught. That is my, so E max is there and this term is there. So RHS, I have got these two terms. LHS is this. Now if I look into this equation correctly, what are the unknown parameters here? E max, I think we should be able to sort out from this. Check that. The result should have a P naught term, V naught, कुछ आ रहा होगा, PATM. So PATM, P naught, V naught. Just observe that AL term, that is not coming in the final expression. So let me just write one equation of PV raised to the, so I think it works. So मुझे ऐसा लग रहा है that P naught into V naught raised to the power gamma, that term was 7/5, is equal to PATM into final volume, and final volume is AL raised to the power 7/5. So मोटे तौर पे ऐसा लग रहा है that I can replace this term V naught by AL by PATM upon P naught, right, raised to the power 5/7. That is my equation number 1. Check. V naught by L हो गया, P naught, PATM upon P naught, and raised to the power 5/7. You can observe this thing keenly and replace the terms appropriately and check what are you getting for E max. AL term can be replaced, na ho jayega. So my only point was your answer should not be in terms of AL, rest is fine. And one more thing, B was straightforward. From the same equation, I think you can find out value of L, that is more of this equation which you had to write. So not that this question directly, but just take care of such concept with some springs, some form of energy is more attached in the problem, which can be put up. I think you can put down the data problem. One thing I wanted you to just, when we are, I mean, the last problem of yesterday's class, you know, we had that dipole here, somewhere here, and it was at a distance of x, it was moving with a velocity of v. This guy was having a resistance of r, and the radius also was given as a. So I discussed it by one method. There are two more ways of looking into it. One way of writing the answer, I'll share it directly, that once I have, I let this dipole move right, you know. So we understood that there is a magnetic repulsive force acting between them. So agent is exerting a force forward, which is of the same magnitude. So if you look into the system from outside, the power that that agent is supplying, F agent into V, that is actually, that can be written as the rate at which the heat is lost from the resistor. System के ऊपर और कुछ तो हो नहीं रहा. So this is also one way. So what could have been written, if somebody can write the EMF induced, uska square upon capital R, this will be fine. And then F agent, yeah, F magnetic will have the same magnitude. So this term could have been written because somebody can say that E ka mod we have calculated yesterday. If you remember your solution, you can just check. I've written the flux through this. Uska rate of change likha tha. So I had written the expression of magnitude of induced EMF in the loop. It was a function in terms of X and V. Uske liye reciprocity I used and everything, and I got it. So I'm not writing it. I think we are clear. And one more method, method 3, could have been used. This is only after writing the induced EMF. Induced EMF के बाद directly ऐसे कर सकते हो. Yeah, you can do one thing. After you get induced EMF, you could have written the induced current in the loop. Simple. So, I mean, I का value आ जाता, that would have been E mod upon R. As far as direction is concerned, I've treated this dipole to have a dipole moment. वो तो उल्टा आ रहा था. So with respect to a guy who is standing here, the direction of current was anti-clock. है ना? Anti-clock था. और अब होगा क्या, इस dipole की वजह से you will have magnetic field at every point on the periphery of that current carrying ring. So if you look at ring like this, right, and you look at the field lines because of this dipole, at every point, you can look at the highest point also. You will have two field lines. One will be radial and one will be along the axis, axial. So everywhere you will have a radial and an axial field. A radial and an axial field, something on that sort. I'll write the function, don't worry. I mean, you understand कि अगर मैं ring को ऐसे देख रहा हूँ and dipole is something that I'm observing like this, so I know that field lines will be like this, no? At these points. So that's why I'm saying axial and radial. And axial magnetic field is not exerting any force, that is uniform. So force is exerted by radial fields only. If there is some BR here, some BR here. And you understand that in this view, if you have BR everywhere, and from this side, current is like this, anti-clock. You apply IL cross B, so you can see that repulsion which is going inside. This anti-clock current and this radial field will exert a force inward. Now, inward, according to this guy, means rightward. So there is that repulsion which is very clear in this combination. And how much repulsion is being carried out? क्या लिखना चाहिए मुझे? The current I का term इसमें total length of this ring, which is 2 pi A, and multiplied by the radial magnetic field. So I into 2 pi A into BR. That is my result. I into 2 pi A into BR. B radial. I think I you got. So only hassle now would have been to write the expression of B radial. And I don't think this is a big problem. If there is a dipole moment M and this radius is A and this angle is, now you can draw that angle and everything. So I think M and I need B radial, not a big problem to write B radial. क्या आ रहा होगा if you treat this as R, this is A, this is X. So I know that there is a magnetic field which is like this. It is 2 mu naught upon 4 pi 2 kp cos theta and divided by R cube, small dipole. And for the other component here, we'll have a field which is in this direction, which is mu naught upon 4 pi m sine theta divided by R cube. So what about this term of magnetic field BR? So BR का value यहाँ से आप आराम से लिख सकते. It comes out as 3 mu naught upon 4 pi m sine theta cos theta upon R cube. R को convert वगैरह कर ले. This may be a lengthy method, not in for the same problem, but theoretically it was fine. So you can just complete this because I saw some students writing in the chat, because here the device is not such that I can directly see your chat box. So after the class, I read that. So that's why I thought I should discuss method 2 and 3 also. Somebody was asking this point. And one more thing was there, which I would have written because I used one method to solve it. वो ये था कि while writing E, so I used reciprocity. There is a lengthier method also. Because you know the magnetic field, because of a dipole at every point on a disk. So you can cut your disk into rings, and at every point, the axial magnetic field will generate flux. And then you can integrate over those rings so that you can write the flux on the disk. And then you could find out rate of change to find out the induced EMF. So by reciprocity, one thing, or through this method also you could have solved. So let me now go back and pick up the next problem for the day. So one question I'll take up. No issues, no issues. Whatever is available, I'll just sort it out. Just look into this one combination, which was a nice idea sometime. APHO में पूछा था. So just go through this question carefully. Important from JEE's perspective. In this problem, a bungee jumper was attached to one end of a long elastic rope, and the other end of the elastic rope is fixed to a high bridge. The jumper steps off the bridge and falls from rest towards the river below. It does not hit the water. The mass of the jumper is m, and the unstretched length of the rope is capital L. The rope has a force constant of K and gravitational field strength is G. Now you could solve the problem. मतलब वही extended SHM types combination है. So the jumper can be neglected as regarded as a point mass. Mass of the rope is negligible. You have to obey the Hooke's law. Air resistance is ignored throughout the fall. So there are a few things he is willing us to answer. Distance stopped by the jumper before coming instantaneously to rest for the first time. Maximum speed attained by the jumper during his drop, and the time taken during the drop before coming to rest for the first time. So just try to write these results. I'll go through them quickly. Look into A. So here there are two things. No? Whatever he would have fallen, so his natural length was L. Na? So mg, that natural length L plus that extension, let me treat it as y, and that is simply half of K into L square. We can solve this equation for what? Y? क्या पूछा था उसने? This was a y square, yeah. That is the extension, right? So y is one thing which you could have written. Just the C part of the question is what I am more interested into. B was the maximum speed during the drop. What I should have written? Directly I could have written as A omega. I'll write this answer. Omega is simply root K by M. Now my only concern is value of A. Right? So if I look into A, so the velocity root of 2GL jo aaya hoga na, while you have dropped L, that should be equal to omega, which is root K by M, into root of amplitude square minus distance from the mean position, and that is mg by K the whole square. Just check this equation and you solve it out and look up for the positive root here, and I think that works. Look for the positive root. It's fine ना? कि जहां वो पहुंचा था वो velocity root 2GL था और mean was below that. So looking into a extended SHM kind of problem, I have written that. So that will work out for A. The answer for B part will be this. C part you have to be a bit careful when you answer, because for C part you should have drawn phasor diagram, maybe whichever way you are comfortable. So मुझे तो ऐसा लगता है y is equal to 0 is my mean position, but y is equal to, I mean, this is mg by k. So actually this problem is like this from here to here. So I mean, पीछे का motion ऐसा नहीं है, but you understand this point. So this is my phasor diagram, and actually this is the phase angle I will move when I will just enter into this phasor, I mean this SHM at this point. So out of this complete SHM, I'm just looking into this patch. और ये radius A है. So time, so answer for C part should be root 2L by G तो लगा ही होगा time in air, and plus remaining time. So remaining time is the phase angle. So if this angle is theta, it is theta plus pi by 2 divided by omega. Omega is root of K by M. That is my result. And what can I say about theta here? So you can check If you write the expression of sine theta, so sine theta here comes up as mg by k into a. This is the expression of a sine theta, और मेरे ख्याल से a का वैल्यू आपको दे रखा है. A I have already calculated from the previous equation, bit of calculation, but that will serve the purpose in the problem. So just go through these ideas which I have picked up from the perspective of the examination, and these small ideas will be helpful for all of you. I'll finish off the class here, and we will pick up more common combinations in the classes to come, right? So take care.